In Standard 2, we're going to continue to look at functions. Here we're going to focus on how to evaluate functions and how to solve functions in various contexts. So you saw in the previous video how we looked at the graphs of functions, and those graphs were a way of representing of a function. And we also, along with that, had the equation. But functions can be defined in a ton of different ways. And so in this first example here, what we're going to do is define it as a table. So when a function is defined as a table, then basically what you see is what you get. So what I want to remind you of here is the picture of the diagram that we drew in the very first video, where we think of a function kind of as a machine, right? So you're sending x values into the machine, and then outputs are coming out the other side. We use the idea of a grocery store scanner, right? You scan items at the grocery store, and it spits out a price. All right. So when we're asked to evaluate a function for a particular number, what we're being asked to do is to take this as the input. Notice it's replacing x, right? So -2 is the input here in part A. It's replacing x, so that literally means that I am placing a -2 in the spot of x, and then being asked what comes out the other side. But according to the table, we know exactly what comes out the other side. We know that when you put -2 into this function, a -1 comes out the other side because it's listed right here. So our answer to that question is just that f of -2 is equal to -1. And so similarly, if I want to know f of 1, we're saying, okay, plug 1 in for x. What comes out the other side? Well, we can see that nothing comes out the other side, right? Because there's no 1 in all this list of x's. So what we would say here is that f of 1 is undefined, right? Because there's nothing that if you plug 1 in that comes out the other side, because the table doesn't have a 1 there for the x value. All right, so that's what we do when we evaluate a table. Is if the number's there, great, tell me what the output is. If the number's not there, then we would say that that's undefined. Okay, it would be kind of like this 1 is kind of like, you know, trying to scan something that doesn't have a barcode on it, right? Nothing's going to come out of the cash register when you're trying to scan something that doesn't have a barcode. All right, the other thing we want to do is be able to solve. So in this first one, it says solve f of x is equal to 7. Well, remember that f of x is the y value, right? So in other words, it's saying, okay, solve when the y value is equal to 7, what is x? And we'll even write that out. When y, or the output, is 7, what is x? All right, so here in the diagram we are saying we know that 7 comes out the other side. So what had to go into the function in order to make 7? So I'm going to go find 7 here in the list of y values and note that it came from x equals 8. So my answer here is x equals 8, because that's what you would send into the function in order for 7 to pop out. All right, f of x is equal to 3. Okay, so we want to know, kind of running out of space here, but if I put a 3 here as the output, what could 3 have come from? Well, the answer here is a little more complicated. If I look in the table, there are 2 places 3 shows up as a y value, and it comes from 2 different x's. So remember our discussion earlier about how it's okay for 2 different inputs to give the same output. That's not a problem. So this output of 3 comes from these two different x values. So you could put in a 2 or you could put in a 4. So what I would say my answer here is x equals 2 and x equals 4. Those are both acceptable x values to give you a y value of 3. And then finally, f of x is equal to 0. So we're saying, okay, if 0 came out the other side, where did it come from? But since 0 is not one of the outputs, there is no input that it came from. And so in this case, we want to kind of say the same thing, sort of thing we did in part B, but we word it differently when we're solving. We say that there is no solution. All right, so let's take a look at another example here. This time, instead of a table, we have a graph, but there's no equation that goes along with this graph. And so let's do the same sort of process here. So in part A, it wants us to evaluate g of 3. And so remember that what this means is we want to know what is y when x equals 3. Okay, what is y when x is equal to 3? So when x is equal to 3, I go over 1, 2, 3 in the x. What is my y on the graph? Well, my y is 0, right? And so that means that g of 3 must be 0. All right. Now I'm going to skip over part B for a second. Let's go down to C. It asks me to solve g of x equals -4. Okay, so what we're saying is we know that the y value is -4, right? What is x? So what is x when y is -4? Okay, so now I start by going down the y-axis and finding -4. And then I ask myself, what are the x values that go with this y value? And the only one I see is this dot over here, right? So I follow y equals -4 over till I hit the graph, and then I note what the x value is here. The x value is 5. So my solution is x equals 5. Now in a moment I'm going to do B, D, and E, but I think this would be a good time for you to pause the video and try to get B, D, and E yourself. All right, so hopefully you've given B, D, and E a good try and have answers for those. You might have been a little puzzled by E, and if you were, that's okay. I'll show you how to work with that. But let's check out this one, g of -4, right? So you should have realized the -4 is the x value. So I'm going to go over 1, 2, 3, 4 in the negative direction, and I'm going to ask myself, what's the y value? The y value there is 3, or -3, excuse me. So -3 should be our answer for part B. Solving g of x equals -2. So we would say this time the y is -2, and so I'm going to go down 1, 2 to -2 in the y. And the first thing I notice is if I go over here, I hit the graph, and that happens at x equals 4. Okay, so I'm going to list x equals 4 there. But that's not the only place that it hits the graph, right? It also hits the graph over here at x equals -3, and over here at x equals -5. So in this case, I'm going to have three different solutions to this equation. And so one thing I just want to point out here is that anytime I'm asking you to evaluate a function at a given number, you should only ever have one answer. And the reason for that is because in order for something to be a function, every x can give you only one y as an output. However, you can have multiple inputs going to the same output, and that's what we're seeing here. The inputs of 4, -3, and -5 all lead to a y value of -2. So when I ask you to solve, you might have multiple solutions. All right, now part E, let's take a look at this one a little more closely. You might have been a little bit perplexed as to what to do with this at first. If you were, that's all right. But the point is, if you look at parts C and D, if we can make something look like g of x equals a number, we've had practice at figuring out what the answer is. So what I want to do is get the g of x by itself so that it can look like C and D. So of course, if I add 2 to both sides, that would be algebraically legal. And you'd get 3 times g of x equals 12. And then if I divide it by 3 on both sides, I would get g, oops, let me go up here, g of x is equal to 4. Okay, now that looks just like parts C and D. So when g of x equals 4, what's happening? Well, I'm up here at a y value of 4. What are the x's? -1 and 1. So I'd put an answer of x equals -1 and of x equals 1.